Okay, right, this is where it gets a bit more difficult. So what we've got to do is we've got to write expressions for the vectors x and y in terms of a, b and c. A, b and c are just vectors, okay? So let's just think about it here. We've got to try and find out what this vector y is. Now, what you have to realise is that you can't go along this path. You can't do it because you don't have any information, okay? So you can go an alternative route. What you can do is go along A, then move along B, and then you see there that you're going the wrong direction down C. Okay, so what are we actually doing? Because they're top to tail. Well, if they're top to tail, it means I can add them. So it means y is equal to A plus B. And then since we're going in the wrong direction down C, we know we're going in the wrong direction because C's arrow goes in this direction. We're going in the wrong direction, so we're going to take it away. Okay? Now, what do you notice about x? Do you notice that x is going in exactly the same direction as y, but it's only half the distance? So x is going to be equal to a half a plus b minus c. It's exactly the same direction, but only half the magnitude. And I can expand that. All this stuff works like normal algebra. So I'm going to get half a plus a half b minus a half c is vector x. Okay, and vector y was just a plus b plus c. So it's using that fact that when we've got them top to tail, that means we're adding. And if we're going in the wrong direction, then we're taking away. And vectors that are going in the same direction are the same, okay? But the magnitude might be different. The size might be different. The length might be different, okay? So here's an exam style question. This stuff is quite tricky, okay? So it's that ABC is a triangle. AB is equal to U. So let's just make sure that the arrow is clear. BC is V, so that's going this direction. Okay. Find the vector AC in terms of U and V. So what I want to do is go from A to C. Now basically I don't have any information, so I can't go there. So what I'm going to do instead is I'm going to go from A to B, and then from B to C. And those two vectors are top to tail, so all I have to do is add them. So AC, vector A to C, must be equal to U plus V. Okay? Now, X is a point on BC. Okay, here's X. Such that BX, XC is in a ratio of 2 to 1. So what that means is, if the ratio is 2 to 1, then this bit BX is taking up 2/3 of that length. And the bit from X to C is taking up 1/3 of that length. Okay? Basically, I split it into 3 parts. 2 of those parts belong to BX, and 1/3 of those parts belong to XC. So don't be confused. It's not it's not a half and 1/1. It won't make any sense. Okay? It's 2/3 taken up by this bit, and 1/3 taken up by this bit. So we've got to find the vector AX in terms of U and V. AX. So we're trying to find this here. Well, again, I can't do that. So what I'm going to do is I'm going to go from A to B, and then B to X. Notice there top to tail. So A to X must be U, so that's just A to X, must be equal to U plus only 2/3 of V. Because it's not all of V that I'm going down. I'm only going 2/3 of it. So there we go. D is a point such that CD is equal to 6U plus 4V. Show that CD is parallel to AX. So let's just have a look at this. CD is equal to 6U plus 4V. And AX is equal to U plus 2/3 v. Now what I'm going to do is I'm going to find 3 lots of ax, basically so that I can get rid of the denominator in there. So that's going to be 3u plus 2v. Okay, I'm just timesing each of these by 3. And CD is equal to 6u plus 4v. Notice that this vector, if I double it, I get to this vector. Okay, 3 lots of AX is equal to CD. So that actually must mean that 6 lots of AX is exactly the same vector as CD. Well, so what does that mean? If they're the same vector, it must mean that they're going in the same direction. The only difference between CD and AX is that CD is 6 times longer than AX, but they're going in the same direction. Now, if 2 vectors are going in the same direction, they must be parallel to each other. Here's a vector going in a direction and a vector going in the same direction. Doesn't matter about if it's 6 times bigger. We do know that they're parallel simply because they're going in the same direction. Okay? So I hope that makes sense. So there we go. Now, let's just clarify this again. This was u plus v. This was u plus 2/3 v. And we showed that they were parallel. Right. by is parallel to AC. These are parallel. Means they go in the same direction. And remember that u plus v is AC. Okay? AXY is a straight line. Find BY in terms of u plus v, BY. Now it's very tricky because what they've done here is they've hidden other types of maths into the same question. So this is what I've said to you many times, is that the difficult questions require you to think about more than one topic at a time. Okay? Now just have a look at this. Here is AC, and we want to find BY. Now, what you should notice is that we actually have similar triangles here. Similar triangles. I should know that because they're parallel to each other. So this angle is going to be the same as this angle because they're alternate. This angle is going to be the same as this angle because they're alternate. And this angle are the same because they are vertically opposite. Now, what's the scale factor? Well, we already know the scale factor because we know that this distance is twice this distance, and they are corresponding to each other. So I know that BXY is 2 times bigger than AXC. So I should know, therefore, that BY is 2 lots of u plus v. So it's 2u plus 2v. Okay, so tough because they've combined together similar triangles with vectors, all right? And that makes the question more difficult when you've got to combine 2 topics together. So u plus 3v, which one is it parallel to? Well, I'll tell you now, it's going to be parallel to this one because if I do 4 lots of u plus 3v, I get 4u plus 12v. So that is to say that the direction bit is the same. It's just this one is 4 times bigger than this one. Okay, they're parallel because they go in the same direction. 2a plus b is parallel to which one? It's going to be this one. Okay, the directional bit is exactly the same. K is going to affect the size, the magnitude of the vector. So we don't know how much bigger it is. We know this one is the same direction, but k times longer. Okay. Right, so let's do a couple of these ones together, and then you can do the rest yourself. So, first of all, it's very easy. AB, what's vector AB? Vector AB is just P. Okay, that's clear. We're told it. BA, well, that's P, but in the wrong direction. So that must be minus P. What about BC? BC is easy. That's Q. What about AF? Notice how we have nothing for AF. But remember, vectors don't have a position. So can we find a vector that's exactly the same as AF? Yes, we can. CD is R. And notice that those vectors are exactly the same, just in a different position. Position doesn't matter. So AF is R. Okay, what about FE? Well, FE is the same as Q. Okay, see if you can find the others yourself. Okay, here are the solutions. Okay, DF. How do we go from D to F? Let me change colour so we don't get confused. I'm going to go from here to here to here. Well, that is going backwards Q and then backwards P. So minus Q minus P. Okay. Right, what about this one? Show that the following pairs of vectors are parallel. Stop your video and have a go. Okay. So you just basically factor out any common factors. So 2t plus 6s has a common factor of 2. If you factor it out, you'll notice that you end up with the same vector. So they're the same vector, it's just this one is twice as long as this one. Okay? Same with this one here. You've got to simplify it first. 3p minus p is 2p. 5q minus q is 4q. And then we can factor out 2. So we can show that they are in fact the same direction. Here are the other answers. Okay. Should be easy. Okay, here's where it gets tricky. Stop your video and have a go at it first. Right, find BC in terms of P and Q. So I'm going from B to C. I can't do it, so instead I'm going to go from B to A and then A to C. Notice how I'm going in the right direction of Q, but the wrong direction of P. So it's got to be Q minus P, or minus P plus Q. It's the same thing, okay? D is a point such that AD equals 2Q minus P, okay? Show that BCD is a straight line, BCD. We need to show it's a straight line. Well, I already know what vector BC is. I already worked that out. It's minus P plus Q. I can now work out the vector CD. Okay, so CD, what would that be? CD, I want to go down here and up here. So that's going to be minus Q, I'm going Q in the wrong direction, plus 2Q minus P. And that is going to be equal to minus P plus Q. Minus P plus Q. And that was also minus P plus Q. So what do you notice? They're going in the same direction. Now they're going in the same direction and they share point C. Okay? So we're saying BD and BC originate at B and have the same direction. They're sharing the same points. If they're sharing the same points, it must actually be a straight line rather than them being parallel. Okay? Find the ratio of BC to BD. Well, hopefully it shouldn't be too hard to spot that BC to BD is 1 to 2 because this is halfway. So this is a half, this is a half, the ratio is 1 to 2. Okay? Right, what about this one? PQR is a triangle, PQ equals 3A, PR equals 2B. Find RQ in terms of AB. RQ. So we need to go R to Q, which I'm not going to do. I'm instead going to go from R to P and P to Q. So we can see I'm going to go in the wrong direction down 2B and in the right direction down 3A. So the answer is minus 2B plus 3A. Obviously we can rewrite that as 3A minus 2B if we want to. Okay. X is a point on PQ such that PX XQ is 2 to 1. So that makes this, makes this a third and this 2/3. Okay. Show that Rx, that's Rx, is parallel to A minus B. So we need to find Rx. Rx, we're going to do this. We're going to go the wrong way there and the right way there. So we can see that would be negative 2b plus only 2/3 of 3a, which is the same as minus 2b plus 2a, which is, factor out the 2 minus b plus a. It's the same direction as a minus b, it's just 2 times as long. Okay, so this direction here is the same as a minus b, 2 times longer. Okay, and there we go. Explain the mistake. JKLM is a parallelogram. Stacey agrees that JK and ML, so JK and ML are parallel and the same length. But she does not agree that the vector ML is U. She says ML and JK start at different points, so they can't be the same vector. Okay, well, obviously just being silly, because vectors, their position doesn't matter. If a vector has the same direction and the same size, then it is the same vector. Okay, so they're actually exactly the same vector. Okay, here's an exam style question. Stop your video and have a go. So PQRS is a parallelogram. M is the midpoint of RS. PQ equals A, RQ equals B. Find the following vectors in terms of A and B. So PS. P to S. Well, that is just going to be negative B, right? That's going to be negative B. SM. Well, SM is just going to be half of A. PM is going to be P to S plus S to M. So all I've got to do is add my two answers. So it's going to be minus B plus a half A. And there it is. Okay, minus B plus a half A. T is the point such that QRT is a straight line and QRRT is in the ratio 1 to 2. So probably don't really have enough space here. Let's just put, do you know what I'm going to do? I'm going to try and get some space if I can. Let's see if I can move the picture. How do I move it? Oh dear. Do you know what? No, I won't bother because I'm just mucking things up. Okay. So where is T? T is a point such as QRT is a straight line. So it's over here, but I think actually it's a bit further than that. Okay. QRT. T is over here somewhere because it's on a straight line. But the ratio of QR to RT is 1 to 2. So actually, this would be 1/3 and this would be 2/3. Hence why you can see I think T is way more over to the right-hand side. I just can't put it there. Okay? Show that ST is parallel to PM. Now, what that means, if this is 3B, sorry, if this is B, then this must be 2B, okay, because it's twice as long as QR. So how do I do ST? Well, what I'm going to do is I'm going to go up from S to R, which is A. I'm doing ST. Plus R to T, which is 2B. So ST is A plus 2B. PM, we already found out in the previous part of the question, was a half A minus B. And I've just realised actually, so I've got this wrong because this is B is in this direction. So 2B is this direction. So actually, I got that wrong. This should be A minus 2B. And PM is equal to a half A minus B. So 2 PMs could be equal to A minus 2B. Notice that they have the same direction component. It's just that ST is twice as long as PM. Okay? Why won't that show you the answer? I really don't know why. That's why. Still don't know. Hang on a second, guys. Sorry. Keep. Right, here are the answers. There we go. Let me just delete what's written under there so that you can see it clearly. Sorry for the faffing. Right, there we go. So here's the answer. Okay, so ST is parallel to PM because they share the same direction component. Obviously, ST is twice as long as PM. Its magnitude is double. Okay, all right, we'll stop there. So on this task, I'll be providing you with some worksheets to do to practice this, and there's